Okay, so basically doing the ratios the other day kind of set us up for what we're doing today, okay? So 2.5 is calculating unknown measures in similar triangles. So this is the big keywords here, similar triangles, okay? So similar triangles are two or more triangles whose corresponding angles are equal, and we'll show you what that means. So the angles are the same measure, basically, they're the exact same, and whose corresponding sides form the same ratio. So that's just what we've worked with before in proportions. So these types of triangles have the exact same shape, but they're different in size, okay? So they have the exact same angle measures. Their ratios of the sides are the same. So 1/2 would be equal to 3/6. Okay, so there's equal ratios, but they're different in size. Basically meaning that one is an enlargement of another. So you have one small triangle that looks exactly like the other, but the other is a lot bigger. So if we look at these examples right here, these two examples, they look very similar, right? Like they look very, very similar. They even have some markings on them that show that they're kind of the exact same in certain ways. So if you see, for instance, this right there, that shows that these are the exact same angles. Okay, if you saw an X in there or a square in there or a circle in there, if you see them in both, that just goes to show you they're exactly the same. Same with this check mark. So it shows you that the orientation of these two triangles are in the same spot. And A, so if we look at the vertex A or the point A, it's the exact same as the point X. We see that, right? Like they're aligned with one another. They're different size, but they correspond to one another. They're very similar, okay? And then we have the different sides. So A to B, B to C, A to C, X to Y, Y to Z, X to Z. You get that those are different side lengths, right? So you'll also see that we have 10 centimeters and we have a Y, okay? So the Y just goes to show us calculating the unknown measures. So in this case, it's just Y. That's our unknown measure here, okay? So all we're doing is setting up a ratio based on these two triangles. So if I had the ratio, since we have the two sides here, 10/8, okay? A to C, so this side length is similar to what side length on the other one? Y or X to Z, right? So if we set up the ratio, since I have 10 on top, it would be Y over, and 8 or B to C is the same as what on this one? Yeah, or Y to Z, right? There's this similar triangles, and they're not the exact same, but they're very similar. So the ratios are set up just like this. Okay, so we have similar side lengths, we have the same angles, and we've got the same ratio. So based on what we just did before, what would be our method that we use to find out Y? Cross multiplication, right? So we're going to take this and bring it up there, and we're going to take that and bring it up there, right? Since it's division on one side, to bring them to the opposite side, it becomes multiplication. So then it would be 12 times 10 and 8 times Y. Okay. So 12 times 10 being 120, equaling 8Y. How do we get Y by itself? We divide both sides by 8. So once we do it on this side, they cancel out. And once we divide 120 by 8, what would our answer be? Go for it. Take your time. 15, exactly. So then our unknown side would be 15 centimeters. Okay. So we're given two similar triangles. We just got to figure that out. Now, those are very easy examples because they're the exact same orientation. What does the word orientation mean? Don't really know. So meaning that they're on the same plane. So if I had like two pencils and they were up like this, they're the same orientation. If I had one like this, they're different orientation. Okay, so they're not flipped around, they're not messed with, they're not all in different areas. However, our next example, does it look like the last one? No, right? But you'll notice that it's basically flipped. And how we tell that is because of those different angles. So remember how I said if you see that and you see that, they're the same? So the point B is similar to what point on the other one? E, exactly. And then we have the check mark. So D is the same as what point on the other, or the similar to what point? A, exactly. So in this case, we know that B to C is the same as, or similar to, sorry, E to C, because it's just flipped over. I know it's really strange to get right now. And then we've got the check mark to the circle. So check mark to the circle is X over here, but it's 3 over there. Does that kind of make sense? A little bit? It's strange, right? Like we're getting different orientation, but we need to always remember, okay, where's the check mark? So I see the check mark in this one. Oh, it's over here and this one over here. So I can orientate myself to that. So I know that the check mark to the dot, or those two angles, check mark to the dot is 3 centimeters. Check mark to the dot over here is X. So that's the unknown. So when I'm setting up my ratio, I could do it this way. I have 3 over, my only other measure here is 4 centimeters. So 3 over 4 is equal to, we always put the equal proportions laterally across from one another. We don't put them wherever we want. So in this case, 3 centimeters is equal to what over here we talked about? X over, what's our other measure? Perfect. Now we have a ratio, right? We can do this no problem. Proportions, what do? Yeah, we call that what? You got it. So 3 times 6 equals 4 times x. So 18 would equal 4x. Then we got to divide both sides by 4. 18 divided by 4 is what? Use that calculator. It is, yeah, 4.5, exactly. So then we know the unknown, or x, is 4.5 centimeters.